linear functions. I wonder what linear means. Let's sketch some and see. So our lesson opener, they want us to plot these 2 points and sketch a line between them. So why don't you pause, take a moment, do that while I do that. Okay, do yours look like mine? As it leads us into this next question, it starts to talk about slope, because right, these are straight lines, so linear functions must mean straight lines. So slope measures the steepness of a line. Calculate the slope for each line by looking at the vertical and horizontal change between the points. Think of a slope triangle. So let's look here. So vertical change between the points. All right, so I'm gonna work from this point to this point so I can kind of draw this triangle in here. So the vertical change, I'm heading up. Looks like I head up about 5. So my vertical change is gonna be 5. And then my horizontal change, so that's this direction. So as I travel to this point, completing that slope triangle, right? I travel over 3. Miss Pierre, where am I getting that 5 and that 3?
Well, we know that we can calculate that, and I'm sure you've done this before, but let's really make that connection. So we have our point up here, which is at 4, 7, and the point here at 1, 2. And if we're talking vertical change, of course we meant this, and Miss Ryan went 1, 2, 3, 4, 5 and just counted, because why wouldn't you do that? But let's say we don't have the line and we just have the 2 points. Well, how did we get 5? Well, let's take a look at the y-coordinate, because we're talking the vertical change, y-axis, right? So that would be, well, sure enough, 7 minus 2. So if I went and labeled these points, x sub 1, y sub 1, x sub 2, y sub 2, then basically what I'm saying is to get the vertical change, do y sub 2 minus y sub 1. And you can see where this is going. So how did I get 3? Well, I have a guess. It's going to be the same idea. The x-coordinate minus the x-coordinate of the 2 points, because now I'm talking about horizontal change. So of course, 4 minus 1 is 3. Where did that 4 come from? Right here. So x sub 2 minus x sub 1. I'm going to let Miss Ryan tag back in.
Wow, okay, so if we want to write down the slope formula, slope we refer to as m, it looks like it's the vertical change over the horizontal change. So I'm just going to write that. So it's really the change in the y over the change in x. So we have this cool little symbol we can use called delta. So delta y means change in y over delta x. So, you know, just if you want to look real smart sometimes. So then we can match that up to what Mrs. Peart was talking about. So we've got our y sub 2 minus our y sub 1 for our change in y, divided by our x sub 2 minus x sub 1 for our change in x.
We graphed 2 lines, so let's double check that other line. You'll see that I went ahead and made a slope triangle. Always going from left to right is usually best. And I want to go ahead, and this time I'm just going to count down. So I'm counting down 5, 6, 7, 8. So I went down. Down would indicate like a negative. And then I went over positive 1, 2, 3, 4. So already I know that the change in y over the change in x is negative 8 over 4, negative 2. But let's check that with our y sub 2 minus y sub 1. So we have our x sub 1, y sub 1, x sub 2, y sub 2, and let's do m equals negative 3 minus 5 over, divided by 3 minus negative 1. So minus a negative is plus, and I get negative 8 over 4. It's always nice when it comes together and works out the way it's supposed to. So m, or slope, equals negative 2, because it's falling. So now we've seen how we got the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You know that change in y over change in x. Let's go ahead and have you practice, and please do take time to practice. You might be going, I know this, I did it in Algebra 1. Yeah, well then prove it, it won't take you too long. It will be helpful sometimes to go x sub 1, y sub 1, x sub 2, y sub 2. The other thing is, doesn't matter which one is your first point and which one is your second point. It actually doesn't matter whatsoever. So if you wanted to flip-flop them and try, you're welcome to. But go ahead, pause the video, do A, B, and C, and we'll come back in and check answers.
Okay, let's see how you did. So for A, it looks like we've got our change in y over our change in x, and I got m equals 2. Did you get m equals 1/2? Then you're mixing up your x's and your y's. Remember, it's gotta be the change in y, that vertical change on top, divided by my horizontal change. For B, this one had something a little weird happen. So the correct answer is m equals negative 5/2. So be careful, because see this 4 right here? When I'm doing minus negative 4 minus a negative 4, those double negatives become a plus. So that's why this reads as plus 4. So just keep your eye out for that. Then my last one, I don't even have an answer for yet, because look what happened in my denominator. I have negative 7 over 0. Oh my gosh, I'm dividing by 0. What do I do? Hello? Thou shalt not divide by 0. That is one of our math commandments. So I want you to always remember that. If I ever start it, thou shalt not, what do you say?
Divide by
Divide by
0.
zero.
Say it. Thou shalt not.
Divide by 0.
All right, let's go. So for this, when we're talking about slope specifically, we say the slope is undefined. And really, if we take a quick snapshot, if we think about this, the x is 9, the x is 9. If we went to graph this, we'd be over here at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'd have 3 and -4. All of a sudden, it'd be a vertical line. It's not a function.
Wow, so undefined slopes mean I have a vertical line. Okay, well let's check out this next section. Here we have 4 graphs and they're asking us to match the correct description, positive slope, negative slope, zero slope, or undefined slope to the correct graph. Okay, so for this first graph, I have kind of this, slanted linear line, right? So my way of telling if I have a positive or negative slope, I kind of just always draw a little car on the leftmost part of my graph. And I try to put myself in that car. And I'm like, okay, right here, if I press on the gas, is my car gonna start rolling up a hill or down a hill? Well, if I press on my gas right here, my car starts rolling down a hill. So that means I have a negative slope. So I'm gonna write negative slope here. Okay, this next one, hey, that's a vertical line. So what did we just learn? That's an undefined slope. Okay, here I have a horizontal line. Well, what do you think happens to a horizontal line? What's my slope? What's my rise? I'm rising 0. There is no rise, so my slope is 0. So this last one, I've got this slope. Okay, I'm gonna put my car on the leftmost part of my graph, press on the gas, and I start rolling uphill. So this one is a positive slope. So if I'm going downhill, negative slope, uphill, positive slope.
So let's talk about writing the equation of a line. And it's always nice when we can just kind of elaborate on something that we've learned previously. So look, I've given you the slope formula. Wrote it slightly different, right? But it's still change in y over change in x. And it says to solve for y minus y sub 1. Notice that it's hugged out. So let's hug it out, right? We're solving for y minus y sub 1. Be very, very, very clear. This is the guy we're solving for. So I need to get rid of or move mathematically that x minus x sub 1. I need to move that difference. It's right now being divided. So to undo division, I'm going to multiply. So I'll multiply by that difference of x and x sub 1. Now I'll go ahead and use commutative property and put m in front. So m parentheses x minus x sub 1 equals y minus y sub 1. There we go. We solve for y minus y sub 1. Well, let's use symmetric property and get that y minus y sub 1 in front. All right, what we've just discovered is the point slope formula. Why? Because all we need is slope, m, and 1 point. So go ahead and write that up here. Y minus y sub 1 equals slope times the difference of x and x sub 1. So when we want to write an equation of a line, if we know 1 point and the slope, we can write an equation of a line. Let's give one a try. For our practice problem, we're going to say we have the point 3, negative 2, and slope is 1/3. Let's label that. So our x sub 1 is 3, the y sub 1 is negative 2, and slope is 1/3. All I have to do now is substitute those values into the formula. So you can see I wrote down the formula, then I substituted the values, and now let's go ahead and clean it up just a teeny bit. So y minus negative 2 would be y plus 2 equals, and I can leave that there unless I have a really good reason to distribute it, and later on we'll learn sometimes we want to, but for now I'll just keep it 1/3 x minus 3. You might say, wait, that's an equation of a line? Well, yeah, because I have enough information to graph a line. So if I took just a moment, let's go ahead and make a quick coordinate plane. Doesn't need to be super neat. Let's pretend we didn't have the point designated and the slope already, and let's just look at the equation and pull it out of that. So if I look here at this equation, we know that that's my y sub 1, but is y sub 1 positive 2? No, because the formula is y minus. So what did I have to subtract to get a plus? I had to subtract a negative. So then I know that my point is going to have this come down and be a negative 2 opposite. The x value comes from here, x minus x sub 1, and it's x minus, so that is a positive 3, so 3. And then, of course, my slope is always right here. So long as I have slope and a point, I can graph any line. Let's go ahead and do that really quick. There's my point, 3, negative 2, and then what do you do with that 1/3? Well, you have a vertical change of 1 over a horizontal change of 3. So we rise 1 and run 3. They're both positive. So I go up 1 and then over 1, 2, 3. Up 1 over 3, and there's our line. Equation of a line in point slope form. Very effective, very quick, very easy, very little room for mistake. We love point slope formula. Let's practice. So for this first one, we have the point 2, 5 and a slope of 3. So let's plot the point and then use the slope to graph the line. So 2, 5 is right here.
And then if I'm gonna use the slope to graph the line, I need to know, okay, well, the vertical change would be 3 over the horizontal change would be 1. So I'm gonna rise up 1, 2, 3 because it's positive and run over 1. Okay, I'm totally out of room here, so I'm gonna plot a third point just to be safe, but I'm gonna go the backwards direction. So down 1, 2, 3, and over the other way 1. Okay, so I've used my straight edge to graph the line, so let's go ahead and write the equation of a line in point slope form. So here, I'm just gonna write point slope form below real quick. Y minus y1 equals m times x minus x1. The way we're gonna remember that is by writing it and thinking it over and over again. Okay, so y minus, guess y sub 1 is 5 equals, my slope is 3 times x minus x sub 1 is 2. So I have my equation of a line and I have my graph. So why don't you take a moment and try the next two. When you get to C, be careful. You kind of might have to use Miss Peart's strategy here where you identify the point and the slope before you go to graph it. On B, the equation of the line is y minus 5 equals negative 4 times x plus 1. Did you get x plus 1? Really be careful there because it's minus a negative 1, so plus 1. And then my negative sloped line is drawn on my graph. On C, I want to make sure you're identifying that point correctly. So I went ahead and wrote my point slope form below my equation. I can see that, okay, my y sub 1 should be 2 because those negative signs match up, so I can just say 2. And then my x sub 1, well, it's minus x sub 1, and I have plus 4. So my x sub 1 has to be negative 4. And then my slope's just sitting right out here, negative 2/3. So then I'm going to go graph that real quick, and you can officially check yours. And there's my graph. Let's move on to write some more equations of lines.
Okay, our directions are still to write an equation of a line, but this time I have 2 points. Oh, are you trying to trick me? Not gonna happen. So I'll go ahead and find slope. So I labeled my points x sub 1, y sub 1, x sub 2, y sub 2, and then I did the vertical change over the horizontal change, and I got 7/5. Now I need to write the equation of the line. Well, I need a point and slope. I have 2 points and slope. Well, that's fine. I just have extra info. Let's just use one of the points. Now this one's already labeled x sub 1, y sub 1, so I'll probably use it, but I want you to know that honestly, I can use either one and it describes the exact same line. So this looks a little interesting. Y minus 0, I can just write y. 7/5 parentheses x minus a negative 5. Let's go ahead and clean that up, x plus 5. Obviously, once again, I could do more work, but if I'm not asked to, why would I? So stop there. Go ahead and try that next one. Let's see how you do. Okay, check your work. And you'll notice that I went ahead and did it both ways. So I wrote it with each point. Once again, just trust me, these mean the exact same line, and we'll prove it later. Moving on, let's simplify A and B from above. So we already had those written out. So we had y minus 5 equals 3 parentheses x minus 2. So we're just going to practice some of our simplifying equations. So y minus 5, I'll go ahead and distribute the 3. And last but not least, I'll add the 5. You might be thinking, huh? Okay, what about B? I'm going to write it down, but I want you to pause, do it yourself, and then check with me. Boom, there we go. You've learned a lot here. Take a moment, think back through, look at your notes, and make sure that you are really looking at this to learn.